Hello, Unite, and welcome to our next lesson. Today we're going to be looking at solving inequalities. We're going to be doing this systematically, similar to a way that you've learned to solve equations. Okay, so for these first examples here, solve these inequalities for x and graph the solutions on a number line. Let's go through it. So for part A, we need to rearrange this inequality just like we would an equation by moving we want to try and get that unknown on its own. We're going to move the other components in that expression to the other side of the inequality to find out what x is greater than or less than in this case. So let's do this part A together. 3x minus 16 is greater than 8. I can move that 16 across. And it's going to become 3x is greater, make sure you keep it the same sign, 3x is greater than 8 plus 16. I've just moved the 16 over to the other side and I've made it positive, just like you would with an equation. Okay, so for our next step, we can say that 3x is greater than 24, and then we can divide both sides by 3. So x is greater than 8. Okay, so we have solved this inequality. Now we need to graph it on a number line. Now the way that we do this, we're going to draw a number line. Okay, let's put 0 here, and let's put 8 over here. We don't have to put all of the numbers. Let's just put some key ones there. Now we're saying that x is greater than 8, but x cannot equal 8. So the way that we show this is we draw an open circle over the 8 on the number line, and then draw an arrow in the direction that 8 can be. Because it's greater than 8, it needs to point to the right. So we've graphed it on a number line by doing an open circle because it's strictly greater than 8. And then we're pointing to the right. Those are all the values on the number line that 8 or that x can be, or the ones that are greater than 8 as such. Let's do another example. So B, got 3 minus 4x is less than or equal to 15. Let's move the 3 across so we get minus 4x 15 minus 3. Let's just clean that up a bit. 15 minus 3. Okay, and then we can simplify. Minus 4x is less than or equal to 12. Now, we need to be careful here when we are dividing both sides by a negative. So in inequalities, let's consider if we were to plus 4x to both sides, we would be moving minus 4x across. So what I'm going to do now is I'm going to show you two ways of doing this. I'm going to show you a long way and a quick way, and hopefully you see that both are the same thing. I'm going to add 4x to both sides and take away minus 12 from both sides. So it's going to be minus 12 over here and positive 4x over here. So I've added 4x, so this cancels out, moves over here. I've taken away 12, this cancels out, moves over here. And you can see the order of our inequality now. It's now minus 12 is less than 4x. We can now divide both sides by 4, and we get minus 3 is less than or equal to x such. Okay, I'm going to show you another way, starting from this line. So 4x. Okay, this time we're just going to divide both sides by negative 4, and then we're going to flip the inequality sign. Whenever you divide or multiply both sides by a negative in an inequality, you need to flip the inequality sign. So times or divide by neg, flip inequality. That's what we need to remember. Okay, so let's do that. 12 divided by minus 4 becomes minus 3. And we get x is greater than or equal to minus 3. Now, is that the same answer as we had before? You can see the inequality is the other way, but you can see x and minus 3 are on different sides. So you have minus 3 is less than x, which of course is the same as x is greater than minus 3. So you see, if we didn't flip the inequality sign here, we would end up with a different answer that would be incorrect. So whenever you multiply or divide by negative, flip the inequality sign to get the correct answer. So now we can graph this on number line. Here's a number line. Let's put 0 here. Let's put minus 3. Always put negative numbers to the left of 0. And now x is greater than or equal to minus 3. So this time, because it can equal 3, we're going to do a closed circle above the minus 3. So instead of an open circle, when we had strictly greater than, we're going to do a closed circle because it can also equal minus 3. That is a valid solution. All of the other valid solutions are the ones that are greater than. So we point the arrow again to the right because x can be any number greater or equal to minus 3. So that's what we indicate. If the sign was the other way around and it was less than, we would of course point the arrow to the left, showing all the numbers that are less than that number. Okay, we're going to do 2 more quick examples down here. So solve these inequalities for x. This time we've got x on both sides, but we can treat this similar to an equation. If you are adding or subtracting numbers, you don't need to flip the inequality sign. It's only if you're multiplying or dividing by a negative number. So for part A, we can add 3x to both sides and take away minus 3, and we end up with 5x. So when I say take away minus 3, I just mean take away 3. So it equals 5x is less than 10. You can see we're taking out 3 from 13 to get 10. We've added 3x to 2x to get 5x. Okay, and now we can divide both sides by 5. And we get our solution x is less than 2. We don't need to graph them on another line for this question. For question B, we're going to do similar things. We're going to take away 5 from both sides, and we're going to minus x from both sides. So we end up with minus 4x is greater than 2. Take away a 5 from 7, you get 2. Take away x from minus 3x, you get minus 4x. Okay, guess what's going to happen here? We're going to divide both sides by minus 4, and we're going to flip the inequality sign. All right, so flip the sign. 2 divided by minus 4 is going to be minus a half. And we have solved our inequality. X is less than or equal to minus a half. Okay, hope you've enjoyed this video. Good luck with the example questions, and I'll see you in the next video.